physical properties of geometrical isomer. So, sometime in reasoning type questions, some questions were asked about the stability, dipole moment, boiling point, solubility, melting point. May ask by giving two compounds. In on this type of compounds can be properties means any questions they may ask the properties related questions. So we have to little bit knowledge about the physical property of geometrical isomer. About dipole moment, this is the cis isomer, this is a trans isomer. The cis isomer bromine has a higher electronegativity, so it will attract more electrons. So this dipole moment will like this dipole moment bromine will like this. So resultant dipole moment will be like this resultant dipole moment. So now here this bromine atoms will dipole moment in this way, this bromine atoms dipole moment in this way. So dipole moments cancel each other. So dipole moment of cis isomer has resultant dipole, while in trans isomer dipole moments cancel out. Here the dipole moment are cancel out, but here resultant dipole moment are generated. So dipole moment of first compound is higher than second compounds. Boiling point, higher dipole moment, higher polar molecule will be higher boiling points, means this is a more polar. Higher dipole moment is more polar molecule having higher dipole moments, higher boiling points due to intermolecular force of attractions. Here higher will be the polar molecule, higher will be dipole moments, higher will be boiling points. Solubility, more polar molecule are more polar in the water. Here is this is the more polar, so it is more soluble in the water. This is the less polar, means they are dipole moments cancelling each other, so they are less polar, so they are less soluble in the water. More polar molecule are more soluble in water. Melting point, better packing structure of molecule having higher melting points. More symmetric isomer higher melting points due to better packing in crystalline lattice, and trans isomer are more symmetry than cis, means higher symmetry, higher packing efficiency, higher will be the symmetry, higher will the melting points, because as melting points this is polar, so the structure will be deformed, and so this have less packing, less symmetry. So these compounds have a more symmetry. So this is having higher melting points than the cis isomer. Now these conditions will stability. Higher will be symmetry, higher will be the stability is higher. The stability of the molecules depend on the van der Waals strain are less. The molecule having more van der Waals strain are less stable. In cis isomer, the bulky group are closer, they have a larger van der Waals strains, means higher will the van der Waals strain, less will be the stability. Here the bulky group, this bulky group in cis isomer are close to each other than this bulky group. In this compound the bulky group are in the opposite sides, but in this cis isomer the bulky group in the same side, so this gives rise to higher van der Waals strain. This higher van der Waals strain decreases the stability of compounds. These compounds less will be van der Waals strain than cis isomer, so these compounds have higher stability than the cis isomer. So trans isomer will be more stable than the cis, so compound second is more stable than first one. Now similarly we apply the second examples, physical properties. Dipole moments, these compounds dipole moment in this way, and this compounds dipole moment in this way, but this dipole moment in this way and this dipole moment in this way. The resultant will be in this way, but here the resultant will be like here the resultant will be approximately resultant will be in this way. There is a chance, but here the dipole moments will be more. We can clearly see that this dipole moment definitely will be more than this dipole moments, because there is a turning of dipole moment, but here is the directly in this way dipole moment in this first compound. So dipole moment of first compound is more than the second compound. Boiling points, more will be dipole moment, more will be polar structure, more will be the boiling points. Now first will be more solubility, more will be polar molecules, more will be solubility. The solubility first is more polar molecule are more soluble in the water. Melting point, better will be a structure packing, better will be symmetry, better will be melting point. Here these compounds, this in the opposite side, but this compound this in the same side, so these compounds have a better packing, better symmetry than this compound. So melting point of first is more than second. Stability, van der Waals strength, we have to see these compounds are in opposite side, but these compounds in the same side, so here will be higher van der Waals force, but here will be less van der Waals force, but less van der Waals strength, here will be more van der Waals strength. So less van der Waals strength, the more will be stability, more will be van der Waals strength, less will be stability. So first compound will be more stable than the second compound. And in this way we have completed the geometrical isomer. Now we will learn about the optical isomer in detail.